Hi guys, today we're going to be covering some of the theory behind Boolean operations and give some examples of why you might use them. So, before we get into Boolean operations, let's first talk a bit about what a Boolean is and what we use them for. A Boolean can only contain one of two possible values, either true or false, and we often use it in conditional statements to control program flow. For example, let's say we're writing a program to handle online deliveries for a business and you only want to send out the package if the customer's paid. We can use a Boolean to let the program decide whether it should send out the package or not. There's only two states for if a customer's paid, either they have or they haven't. In this case, if the customer's paid, then we'll set the Boolean to true and we'll send out the delivery, and if not, then the Boolean will be false and we won't send it. So, what are Boolean operators? These operators allow us to connect two or more expressions that have an output of true or false to help control program flow. In this video, we'll be going through some common Boolean operators and where you might use them. Going back to the online business, it's all well and good checking that the customer is paid, but it's not going to be much use to us if we haven't got a delivery address. This is where the AND operator comes in handy. Let's say we have a second Boolean that's true if a customer has given us a delivery address and false if they haven't, and we want to only send out the parcel if we have an address and the customer is paid. We can use an AND operator to evaluate these conditions. Using an AND gate means that the expression will only return true if both the customer has given us an address and has paid. Otherwise, the output will be false. Let's take a look at the truth table for all possible combinations we could have for this expression. Firstly, the customer is paid and we have the address, so the output is true and we can send the parcel. Secondly, the customer has paid, but we don't have the address, so we don't send anything out and the output is false. Thirdly, the customer hasn't paid, we have the address, but the output is false, so we don't send anything. And finally, the customer hasn't paid and we don't have an address, so the output is also false. The AND gate first checks the expression on the left and then the right. So let's look at another example. In this example, we aren't using two Booleans, but rather comparing two numbers, and the output of these comparisons will either be true or false, so we can use the Boolean operator on them. The AND first checks if 2 is greater than 1, which it is, and then checks to see if 5 is less than 4, which it isn't, and therefore the output of this Boolean operation will be false. Let's say you've got their delivery address, but you want to make sure that they've included their name. You're not too fussed if it's their first or their last name, or even both. You just want to make sure that there's something down. OR works very similarly to AND in that it evaluates the condition on the left and then the right of the OR. Unlike AND, which requires all of the conditions to be true, OR requires at least one of them to be true for the overall output to be true. So let's have a look at this truth table to see all the possible combinations that we could have for the OR gate. So in the first case, we have their first name and their last name, and so it outputs to true. Secondly, we have their first name but not their last name, and in this case, unlike the AND gate, this will give us a value of true. Thirdly, we don't have their first name but we have their last name, so once again, this gives us an output of true. And finally, we don't have either their first or last name, so we have an output of false. XOR functions mostly the same as an OR gate, with the only real difference being that it's exclusive, which is what the X stands for. This means that unlike the OR gate, XOR will not return true if all of the outputs from the expressions are true, but only if one of them is. Let's take a look at the OR gate we had previously for comparison. So for XOR, the table remains mostly the same except for where both of the inputs are true, and this results in the output being false because, as I've mentioned, XOR is exclusive. Finally, we're going to take a look at the NOT operator. NOT is one of the simplest Boolean operators there is out there. It simply outputs the opposite of what's been inputted, much like you might use the word not in normal conversation. For example, let's say that we want to know if we need to worry about delivering a parcel. We can use the not of our package delivered Boolean to tell us if we need to do anything. So in this case, if package delivered is true, then the not of that is false, and so we don't need to worry about delivering the parcel. If package delivered is false, then the not of that equals to true, and therefore we do need to worry about delivering the parcel. So now that we know the basics of what these Boolean operators do, how can we use them together to create something meaningful? Before we send out the package, we need to know that the customer is paid, that we have an address, and that they have provided a name, whether it be their first name, last name, or both. We might formulate the problem something like this. We first do an AND operation on customer paid and address, an OR on first name and last name, and perform an AND between these two to get our final result. So in this case, the customer is paid and we have their final address, so the output of this operation will be true. Second, we'll evaluate first name or last name. In this case, we'll say we only have their last name, but because this is an OR gate, it will also return true. And finally, we'll perform an AND on the results of those two operations, and given that they're both true, the final output will also be true, and so we'll send the package. So that wraps things up for Boolean operators. There are others out there, but we've covered the theory behind the most common ones you're likely to come across. Thanks for listening. We hope you found this overview of Boolean operators useful.